So, let me make sure my virtual kids are up too. So what is complex conjugate theorem? Complex conjugate theorem is basically stating that if you have an imaginary zero, which we do, there is always also the conjugate of that zero. So if we have this imaginary zero that they gave us, there also exists an imaginary zero where it's a minus sign instead of the plus sign, and it would be vice versa if they gave you the negative one. So you just change that sign in the middle. And then we need to write a polynomial function in standard form. I'm sorry, I'm lagging, so it's hard to write. With the roots 1 plus 2i, negative 1 minus 2i, and negative 1. So the zeros are going to be x plus 1, that's from the negative 1, and then it will be x minus negative 1 plus 2i times x minus negative 1 minus 2i. It's going to look like that. So you basically always do x minus whatever your root is, which is what we did over here. Minus a negative 1 becomes addition. So I'm going to have to distribute this negative sign onto each of these. Okay? That's going to give me x plus 1 times x plus 1 minus 2i, and then you're going to group these in parentheses and you'll see why. And then this is going to be x plus 1 plus 2i, because I distributed the negative 1 onto both. Everybody see where the signs changed and all that? So now what you're going to have to do is we want to get it in standard form. This is in factored form. That's not what we're looking for. We're looking for standard form. So in order to do that, we're going to have to use FOIL to multiply these two together first, and then we're going to have to multiply it by this. So it's a bit of multiplication, a bit of algebra here, but we're going to use FOIL. So first times first, which gives me x squared, and then outer times outer, that's going to be plus x times 2 plus 2i, and then the inner is going to be plus x times x times 1 minus 2i, and then last will be plus x, why do I keep saying x? 1 minus 2i times 1 plus 2i. So that's what we would end up with at this stage, okay? So this gets a little bit tricky. From here, we're going to have to use the distributive property again. You're basically going to have to FOIL again. So over here, I'm going to distribute the x's, here and here. And that's going to give me x squared plus x plus 2ix plus x minus 2ix. And then here, we're going to have to do FOIL again because we have two binomials again. Technically not really binomials, but they act as binomials. So first times first, that's going to be plus 1. Outer times outer, that's going to be plus 2i. Inner times inner is minus 2i. Last times last is going to be negative 4i to the second power, I squared. Like that. And then we're going to combine and cancel what we can cancel, combine what we can combine, and all of that. So x squared, we'll bring that down. There's no other x squared. I'm going to cross it out. What's x plus x? 2x. These are gone. What's 2ix minus 2ix? 0. Goes away. We're done with those. And then we're left with plus 1. What's 2i minus 2i? 0. And then we have negative 4 times, what's I squared? Anybody remember what I squared is? Negative 1. So I squared is equal to negative 1. In case you forgot that, just a reminder, remember the I chart, I squared is equal to negative 1. If you get it, you can replace it with negative 1. From here, we then just multiply this, and we get x squared equals, or x squared plus 2x plus 1 plus 4, which simplifies to x squared plus 2x plus 5. So you can replace this with a 5 at the end. I'm just going to replace it so I don't have to write another whole line. My pen is still lagging, so this is challenging. So that's what we end up with. So that is the result of multiplying those two binomials together. Basically, these are the factors of those two binomials. They're imaginary. So we have this, but we're not done yet, because we also have to multiply this times this one out here, this other binomial right here. Okay, we have to multiply those together. Okay, so we're going to multiply this times x plus 1. So I'm going to use the area model because I find it to be a little easier when I'm dealing with a 3 and a 2, a binomial and a trinomial. So that's going to look like this. I'm going to draw a box which has 6 boxes in it. You guys remember the area model? It looks like this. And I'm going to multiply x plus 1 times x squared plus 2x plus 5. And then you're just going to multiply the corners. So this is going to be x to the third. This is just x squared. This is going to be 2x squared. This is going to be 2x. This is going to be 5x. And this is going to be 5. Now within this, you should be able to combine these two and these two. And your result is going to be f of x is equal to x cubed plus 3x squared plus 7x plus 5. And that would be your final answer to the question. So that is how you do it. Any questions for me? So we want to find the polynomial in standard form from this. So this would just be x plus 3 from this times x minus 1 times x plus 3i. But complex numbers always come in pairs. So, or this is an imaginary number. Could be written in complex form, b plus 0. So this would be minus 3i, like that. Now, you have a few different options on the route you want to go with this. I'm going to FOIL the last two. You could FOIL the first two first. It doesn't really matter, okay? I guess we'll do that. We'll keep it in order. I'm going to use FOIL on the first two binomials. It's going to be first times first. So that's x squared minus x plus 3x minus 3. And then over here, that's going to be x squared minus 3ix plus 3ix minus 9i squared, like that. Now for the first binomial, we're going to combine our like terms, and when I do that, I'm left with x squared plus 2x minus 3. And over here, what happens to my middle terms? Good, so I'm just left with, and then over here, I have a negative 9 times a negative 1, which becomes a positive. So we end up with this at this stage right here. And now from here, we're going to use area model, because we have a trinomial times a binomial. So I'm going to draw an area model here. So that's going to be x squared plus 9, x squared, 2x, and negative 3. And then I'm just going to multiply the corners. So that's going to be x fourth, 9x squared, 2x cubed, 18x, negative 3x squared, negative 27. From here, you should be able to combine a few things. Well, actually only one. This is the only one you can combine. So your final answer is going to be f of x equals x to the fourth plus 2x to the third plus 6x squared plus 18x minus 27. And that's your final answer. So if you have an imaginary number, okay, you always got to change the sign in the middle. Now if it's just the imaginary number without the other number added or subtracted to it, you don't have to worry about all that extra step, but that's how you would do it.